Okay, I know what you're thinking at this point. Have we not took the derivatives, enough derivatives for a while? Well, you can never take enough derivatives. Derivatives are, it's like bread and butter. It's America and apple pie. And I'll just shut up and go to doing some derivatives. Anyway, these are a few selected that I had some students turn in today. And the first thing I always want you thinking, I mean, what's going on in a problem? Do you have a product rule? Is it just a power rule? Is it a quotient rule? Quotient is, I mean, what is it just a chain rule? I want you to always be thinking this first because it needs to pop in your head. So this problem, look at it. You've got two functions. It's a function x cubed times tangent x, which means the first thing needs to pop in your head is this is a product rule question. So in this case, u prime would be 3x squared. And then we can come over here. Oops, I mean v prime. Then the derivative of tangent is secant square x. So anyway, that's an easy one. And then all we're going to do is u prime v plus u v prime. We're going to substitute into this thing. 3x squared. V is tangent x plus u, which is x cubed times and v prime, which is secant square x. And we can reduce this down a little bit. 3x squared tangent x. Let's see, plus x cubed secant square x. Some of you may be looking at this one going, hey, secant square, that's tangent square plus 1. And you're right, but all that's going to do is get us some kind of a weird looking quadratic thing, so it's not going to help us any. We could do a little bit of factoring because we could factor this into x squared times 3 tangent x. Yeah, plus x secant square x, but even at that, I don't know that that, makes life a whole lot better, but we could go with either of those two answers. Let's see. This is another one. Now again, think, is it product? Is it quotient? Well, look at something. This is the tangent of sine x. This is not tangent x times sine x. This is nothing but a chain rule question is all this is. So the derivative of tangent is secant square sine x times the derivative of sine x, which derivative of sine x is cosine x, times the derivative of x, which is 1. So my answer to this question is just cosine x secant square of sine x. And that is my answer to this problem. It's not pretty and it doesn't simplify, but that is my answer to this question. All right, let's keep going. Same thing here. This is not cosine cubed something times tangent of 3x. Speaking of which, that tangent 3x probably needs like a little, there we go. Let's clean him up. This is cosine cubed of tangent 3x. So that means this is nothing but a chain rule question. So this is cosine of tangent 3x. I'm going to rewrite it like that to the third power. So this is nothing but a big chain rule question. So this problem becomes 3 cosine of tangent 3x to the square times, this is where y'all get lost. All right, we did the whole thing. Now we're going to do the derivative of cosine tangent. So the derivative of cosine would be negative sine tangent 3x. Now we're going to go a step further. The derivative of tangent 3x, so that would be times secant square 3x times, that's right, we ain't done, times the derivative of 3x, which would just be 3. And believe it or not, this is our answer. The calculus is over, and the ugliness is beginning. The answer looks like 9 secant square 3x. Oh, I see a negative. Sine of tangent 3x. And then what we also got? Oh, we've got this cosine square thing here. So this becomes cosine square of tangent 3x. Whew, goodness, he is ugly, but that's what we've got. So anyway, I'm looking to see, I'm looking to see if I can reduce anything. And a matter of fact, I see something very neat staring at me in this one. You gotta remember something. Secant square of 3x. Oh my goodness, sneak me in. Secant square of 3x. Wait a second. That's the same thing as 1 over cosine square of 3x. Wait a second. Nope, nope, nope. I thought we was about to cancel something. Disregard. This is secant square of 3x. This is cosine square of tangent, so they have no relationship with each other whatsoever. Oh, dang. I thought we was about to have something cool happen. We don't. That is our answer. You are ugly, son. But, you know, that happens sometimes. All right, first thing pops in your head. Tell me, quick, go, even though I can't hear you. That's all right. I believe you said u over v. So I'm going to think you said quotient rule here. All right, cool. So u prime would be, let's see, 4 cosine x. V prime would be 2. Oh my goodness, my screen just went jammed up on me. So let's see. The next one, this would be 2 minus sine x. And there's what we got. So now we can come back. U prime v minus u v prime over v prime. So u prime is 4 cosine x times v. Don't know why I made those sound effects. 2x plus cosine x. Oh, it just gets uglier. Minus u, which is 4 sine x times, oh, we got times v prime, which is 2 minus sine x. Oh, it just keeps getting nastier. And all this is on top of v. Oh, I wrote v prime. Excuse me, v squared. Why didn't somebody stop me? 2x plus cosine x, geez, square. Oh my goodness, that's like crazy looking. The calculus is over, but unfortunately the fun is just beginning. Distributing everything in this one, it becomes, looks like 8x cosine x plus 4 cosine square x minus 8 sine x plus 4 sine square x, all this over 2x plus cosine x, boom, square. And now if you're looking, it's like, well, does anything in this reduce in any way? I'm looking, and for a second, I saw like this cosine x and sine x, and I thought for a second, it's like, hey, we might be able to reduce that to 2 sine cosine or something. No, 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 that's none of that. But I do see this. Look at this. I've got a cosine square plus a sine square. And if I remember, that makes 1. So hold on a second. 8x cosine x, and then I'm going to grab that minus 8 sine x, and we could factor that 8 out of that, but it's not going to make it any prettier. Now I'm going to do something. Plus, I'm going to look at these two guys. I'm going to factor the 4 out and have 4 times cosine square plus sine square. Now that is neat, because if I do that, that makes, what happens? That means that all this becomes 1. So look at what this does. So my final answer, I haven't wolframmed it, but I can imagine my final answer probably be like 8x cosine x minus 8 sine x plus 4 over 2x plus cosine x square. And by golly, that's going to be my final answer. That's my story, and I'm sticking to it. Oh my goodness, how about this one? First thing out of my head, boom, that's a U, that's a V. Oh, cool. So U prime, because I see a product here, equals, that would be 3x squared. V prime would be 1 over x. So U prime V plus UV prime, I'm just in turbo mode working these questions. 3x squared times log of x plus u, which is u, Soldier Boy. Oh, sorry, I just had a little Soldier Boy flashback. Yeah. Times 1 over x. And my answer is 3x squared log of x. And then we've got x cubed x. So this becomes plus x squared. Hey, we could do some more factoring here. So this becomes x squared times 3 log x plus 1. My goodness. I am on fire today. Give me another one. Oh my goodness, make it stop. So this is 3 tangent of x to the half. And this is just a chain rule question. So this is going to be 3 secant square of x to the half times the derivative of x to the half, which if you remember the derivative of x to the half would be a 1/2 x to the negative half, which means that is really 1/2 squared x. So I end up with times 1/2 square root x times the derivative of x, which would just be 1, but hey, whatever, I like throwing in there. So my final answer would be 3 secant square of the radical x over 2 radical x. He's ugly, but that is my answer. Whew. Still working. Still. Oh, okay. This has got to be the last one. Somebody's just pulling my leg now. Tangent of. Now notice this is tangent of, not tangent times, cotangent 7x to the half. All this is to the third. This is just wrong, whoever come up with this. 3 times, take the derivative of the entire function, cotangent 7x to the square times the derivative of tangent, which would be secant square cotangent 7x times the derivative of cotangent, which derivative of cotangent is negative cosecant square. Oh, goodness. 7x times the derivative of x, which is 7. Oh, finally. So my final answer is, in all its glory, 21, let's see, negative 21 cosecant square 7x secant square of cotangent 7x times tangent square of cotangent 7x. And if you're sitting here thinking, is there any way this simplifies just because the secant squares? And no, we're pretty much at an impasse here. So I'm going to put a box around him and be like, when I hit this button, there better not be, there's another one. Okay, this is it. And I'm out. That's my U. That's my V. U is 2x. V would be 3 sine. I'm trying to do this without where x times the derivative of sine 5x, which would have been cosine 5x times 5. So my derivative would have been 15 cosine 5x sine square 5x. And there's an x right there. Oh, goodness. I don't know who dreamed of this, but they're mean, they're sick, and they need to be punished. Prison time, that's all I know. And thank you, University of Southern California, for providing my class with this review. Anyway, let's see if we can't fill this in. U prime is, we said 2x times v, which v was sine cube 5x of 5x plus u, which was x squared, times v prime, which this is horrible. V prime was 15 cosine 5x sine square 5x. Make the bad man stop. And so we've got, for a final answer, or is it sine cube 5x plus, whoa, my goodness, plus 15 x squared cosine 5x sine square 5x And yes, we could actually not really hardly factor anything out of this. We could factor out x, and we could factor out sine square 5x. We could do that and be left with 2 sine 5x plus 15x cosine of 5x. Wow, that was hideous, and I'm glad this video is over. I hope in some way it has helped. But anyway, thank you for watching always. I'm going to go get a taco. Bye now.